The broadcast is now starting. All attendees are in listen-only mode.
Why is it not? Good afternoon, and thank you for joining our webinar around replacing MPLS and SD-WAN. I'm Michael Holden, the Marketing Executive here at Bytes. Today I will go through a brief overview of Bytes security partnerships and talk through some of the challenges of traditional MPLS before handing over to Mark Bayne from Cato, who will talk around a new model for WAN, the Cato Cloud, and enhancing security and user experience. After this, we will have a short Q&A. But first, some housekeeping. Attendee lines will be on mute throughout the session, and there will be an interactive Q&A at the end. Please post questions via the chat or question boxes. This is a strategic discussion, and we will not be going into commercials in this session, but discussions around this are welcome with your Bytes account manager after the session. The recording of this webinar will be available afterwards, and I will send you the link. As a quick request from me, it would be great if you could take a few moments after the session to complete a short survey to ensure that we continue to hit the mark with these webinars. So, who are Bytes? Bytes Security Partnerships are the specialist security arm of the Bytes Altron Group in the UK. We here at Bytes aim to marry the agility, insight, and personal approach you would expect from the smallest specialist partner with all the benefits of being part of a multi-billion-dollar group. We are proud here at Bytes Security Partnerships about the technical expertise we are able to offer around the solutions that we deploy, which allows us to enjoy top-tier vendor partnerships and deliver on the technical and commercial side for our customers. At Bytes, we work across the full spectrum of information technology security, from perimeter and next-gen firewall to cloud and mobile security, access and authentication. We also work with both hardware and software. How we add value to business and vendor partners' solutions is via the technical suite of services we are able to deploy. Whether that's looking at security strategy deployment, technology mapping, project scoping, planning, and delivery, or 24/7 direct-to-engineer support. There is a myriad of ways in which we can act as an extension of your IT teams to make sure that the solutions we deploy add value as quickly as possible. That's enough about us. Why a new WAN model is needed. When traffic flow was predictable and the organization was static, it was simple to connect the organization securely, but today's requirements are radically different. That is why today we are here to talk about understanding the latest tools, tactics, and strategies critical to overcoming traditional WAN challenges with Mark Bayne. Mark Bayne is the Director of Sales Engineering for EMEA at Cato Networks. Cato are pioneers in cloud-based and secure global SD-WAN. They were founded by Shlomo Kramer, the co-founder of Checkpoint and Imperva, giving Cato extensive resources in terms of experience. Cato are an emerging and growing Bytes partner with explosive growth in the market. Now we'll be going over to Mark, who will be speaking about rethinking the enterprise global networking and security architecture from the ground up, bringing it into the cloud. Now over to you, Mark.
Excellent. Thank you very much, Michael. Right, so let me see if I can share out the slideshow. Okay, is that visible?
Yes, that is.
Marvelous. Great. Well, thank you very much for taking the time out of your day to join this webinar. And thank you, Michael, for the intro and positioning of this session. So what I'm going to do today is I'll run through not too long a deck, but one which will hopefully give you a good context and understanding of what Cato delivers, the pain points it's addressing, how we go about doing that, and then I'm looking to then run through a bit of a demo using a couple of accounts which have traffic passing over them, so you get a bit of a feel for what the solution looks like, and hopefully leave 5-10 minutes at the end for any questions that might be raised. So What I will now do is let's take it over to the slide deck, and you can see at the first slide here we've got the title is basically referring to us as a cloud native carrier, and this is a slightly new positioning, I guess, for the company, but one that just really aligns to what we do a little bit better than maybe we positioned it previously. And what we're referring to here is that Cato has now taken the approach of delivering services including the WAN, security, and also SD-WAN to the cloud rather than relying on perimeter devices. What we'll do is we'll go through some of the key differentiators throughout this slide deck, but you can see on the right-hand side, we particularly draw out the fact that we have this global backbone. This is pretty unique in terms of the SD-WAN vendors out on the market. There are very few that actually have anything other than the public internet as their transport mechanism, whereas we've developed a global backbone, which we'll talk about, and the advantages that come with that. We've got the SD-WAN functions that most organizations would expect. We'll talk about how we deliver upon those with still having a lightweight device at the edge of the perimeter of an organization's network. But also another key unique feature is the firewalling aspect. It's really the security as a service that we also deliver and is fully integrated into the cloud service that delivers also the wide area network. So our belief is that where it makes sense to converge a number of point features or point products, we'll do so. And we want to deliver it so that you have a far more simplified environment while still delivering the key requirements that you have to be able to provide a secure and optimized wide area network. So just very briefly to put it into context about who we are, Michael already touched briefly upon our founder, Shlomo Kramer, but Shlomo is pretty integral to the company, and really key that he's decided to take the position as CEO of Cato after having also co-founded it, because you may be aware he's quite a serial entrepreneur and has been incredibly successful bringing new ideas, technological capabilities through startups to the market. He did so with Checkpoint, he did so with Imperva, and he's involved in literally dozens of other very successful startups at the moment. Gurshat was also part of Imperva, and in particular what Gur is bringing to the table here is his technical expertise, having delivered a cloud-based service previously, which was in the form of Encapsula, which was delivering web application firewalling and also DDoS mitigation, all based in the cloud, made up of multiple points of presence globally distributed, which is a key component of what underpins the Cato approach, this concept of having multiple points of presence to develop this cloud native carrier approach that we have. Now, we'll talk more about it later on, but we've got 42, in fact now 43 points of presence globally distributed. These are interconnected with tier 1 carriers. We'll go into that in more detail later, but these interconnections between all of the POPs is what forms this cloud environment that the customers are able to then connect into and leverage, both from the security standpoint and also being able to leverage for the WAN in an optimized fashion. So why did Cato really come about in the first place? And really the pain points that Shlomo looked to address when he started Cato was really initiated by the fact that a lot of organizations are moving to this cloud first approach. So the cloud adoption of services has become a primary focus for a lot of organizations. And the more traditional architecture for networks isn't really well aligned for that migration. So whereas on the left-hand side, you would have that more kind of structured and non-agile approach of having MPLS in place and backhauling internet-bound traffic to single locations, having to deploy firewalls in multiple locations and so forth, doesn't really address the needs for when you have a high usage of SaaS applications and also an increasing use of infrastructure as a service, where resources are moving from on-prem data centers over into the cloud. So looking to move towards adopting that approach, you also need to have a look at how you can better leverage the wide area network and also direct internet access. And a lot of these reasons are why SD-WAN came about in the first place, to remove the total dependency a lot of organizations will have on MPLS, even for their internet-bound traffic. So in terms of these areas that we're focusing on, our real sweet spot use case, the area where we address the most problems, is absolutely where organizations have a number of branch offices, a number of locations. Ideally, you get even more value when those are international footprint or global footprint, and also where MPLS is currently being used. So there are a lot of challenges that organizations are facing with MPLS due to the expense for the bandwidth that you get, and also the agility for being able to onboard and spin up new sites, new branches, maybe to meet the agenda of the business. So that combination of needing better agility and also being able to have a wider bandwidth available for the internet-bound traffic is putting that much more strain on the MPLS architecture. Now, the other approach that organizations will take, and maybe this is also in conjunction with MPLS, would be to use the public internet as a means of being able to connect locations together. So this is from a wide area network perspective. And one of those approaches might be to have appliances in each location where you have IPsec to enable the connectivity using the public internet. And although that can overcome some of the bandwidth challenges, it introduces slightly different challenges, again, especially when we're looking at international footprints, where this unmanaged connectivity using the very unpredictable public internet means that not only are you getting appliance sprawl, which you have to manage and configure, but you're also reliant on this unpredictable transport medium, which is not ideal for some more of the real-time and latency-sensitive types of applications. And then the other aspect, which we're very focused on, is how to ensure that the SaaS applications and also resources that have been moved into the infrastructure as a service locations like Azure, like AWS, how we provide also a uniform means of accessing those resources using Cato. So in such a way that you get the connectivity being well managed, it's very visible, it's optimized, and also you're overlaying security into that connectivity. And then the final piece is to ensure that, as you can see on the left-hand side here, when users are not in the office and they may be traveling abroad or within the country, then we're also looking at how we can provide that same level of security, visibility, and connectivity for the mobile users that they would expect when they're in an office that is connected into Cato. So this is really kind of the problem statement. This is where we're focusing the Cato solution. Now, before we go on to what Cato provides, just a couple of points in terms of how we're quite different to the more traditional SD-WAN vendors. The key difference really tends to be down to this lack of a backbone, and also, as you'll see in a moment, the security that we provision within the cloud. So with the traditional SD-WAN solution, you'll typically look at having appliances at each of the locations, and those appliances are going to be connected into the MPLS circuit, which may be pre-existing for a customer, and also connected into an internet circuit to provide an additional means of connectivity between sites and also direct internet access. The key point here is that because they're still reliant on the public internet, then they don't provide a genuine alternative to MPLS. So very often organizations won't have the option, should they want to look at eliminating MPLS because of the reliance on still having that predictable WAN infrastructure, which traditional SD-WAN cannot provide. Okay. Another aspect is that as you're introducing SD-WAN into an environment and connecting it into MPLS potentially, and also onto the internet to provide the direct internet access and the alternative WAN, then you're also now introducing a potential attack surface because you're now connected to the internet.
Please hold.
Okay. Hopefully we don't have to hold. Michael, is everything still okay from the audio front?
Yeah, everything seems fine.
Okay, good. All right. Okay, so as I was mentioning, this new attack surface means that you absolutely have to look at layering on security to ensure that there isn't the risk of compromise for those locations that now have an internet circuit. So other SD-WAN vendors will need to look at third-party partnerships with Zscaler, Palo Alto, et cetera, which is fine, but it's another vendor to work with, and it's an additional cost. And since we've got this heritage of security, thanks to the team that built Cato, it makes complete sense that we build that security into the Cato solution. And taking that a step further, have built it in not to the perimeter, but into the cloud through which all of the traffic will pass. And I'll explain how that works in just a moment. So in terms of how Cato has architected the service, what we've done is we've created this Cato Cloud, which is the combination of the 43 points of presence that we have distributed globally. And they're interconnected using tier 1 carriers, which are SLA bound. And over that tier 1 carrier network that we have, which forms our backbone, it means that we're able to apply certain optimizations that you simply wouldn't be able to apply on the less predictable public internet. Now, what we do is we then take the customer's various corporate elements, such as data centers, HQs, branch offices, cloud data centers, where they might be hosting certain resources, and mobile users, and we securely extend those corporate elements into the nearest Cato POP, into the Cato Cloud. So then what we've formed is a single network through which all of the WAN traffic will pass. So if the branch office needs to reach the data center, cloud data center, or the HQ, the traffic passes through this secure extension we provide into the Cato Cloud over our backbone, providing the security and the visibility and the optimization, and then accesses the other corporate asset. Now that's great for the WAN piece, but of course, each of these locations may also need to have access to SaaS applications, which are essentially public facing. So what we'll also do is then take all of the traffic that is also internet bound, that also passes through this extension that we've created into the Cato Cloud, and there the security is applied, enterprise grade, using various different services, which we'll touch on shortly, to give a genuine alternative, and if the customer wishes, replacement for the on-prem firewall they may be using. And any traffic then passing to the internet is passed through the security services and then exits the Cato Cloud, destined to the public services. So essentially the Cato Cloud becomes this single network which will pass the WAN traffic and the internet bound traffic. And now you have a single place where you can apply the policies both for connectivity between your assets as well as any traffic that is destined to the internet. The next stage is to really answer the question of how we then securely extend those locations into Cato. And if you imagine that this rectangle that we've got here represents the Cato Cloud, we've got 3 icons there representing Cato POPs, and we've got an HQ and we've got a branch office. So there are a couple of ways that you can extend a location's traffic securely into Cato, and one is to use a Cato Socket, which is it's a small, lightweight, designed to be as zero touch as possible device, which will sit at the perimeter of your network, and it will act as the essentially perimeter device, layer 3 from the perspective of routing, through which the traffic will pass and then get extended into the nearest Cato POP. So what will happen is, using one of these 2 versions of our sockets, then a DTLS tunnel, so a datagram-based TLS, UDP-based TLS session will be established to the nearest Cato POP outbound from your location, and that provides this secure extension of the traffic to the nearest Cato POP. We'll talk about shortly in a moment how you can have multiple ISP links coming into these devices, but the key takeaway for this is that they're designed to be as lightweight as possible. They have enough intelligence to be able to perform things like link selection, QoS, data loss mitigation, which we'll talk about shortly, but we do not provide the security services on this device. We do all of that within the cloud, and there are some distinct benefits of doing so. This is really to extend securely your traffic. Now, going back here, the other option that we have is also to use IPsec as a means of being able to connect a location into Cato if we are unable to have a socket positioned into that location. So an example might be a data center you have where, at least for the time being, maybe replacing an existing firewall is just not going to be possible, but you still want to have the benefits of using Cato. So what we can do is, using our IPsec capability, we'll simply establish an IPsec tunnel from the Cato POP down to this firewall device or IPsec capable device, and naturally the parameters are agreed about what can be passed over that tunnel, and that location is then securely extending traffic then into the Cato cloud. Now, in terms of the more traditional approach that SD-WAN solutions will take, where you might have an existing MPLS circuit and you want to augment that, you want to add to that an internet circuit over which you can provide a secondary path over to your other sites, as well as a means of being able to get to the internet directly from that location. We can do that as well. So our socket device is absolutely able to have connected into it an MPLS circuit as well as an internet circuit, and we can make smart, intelligent decisions about which traffic passes over which circuit. So if for a period of time the contract is still running on your MPLS and you want to make use of that because you're paying for it, we can absolutely decide which traffic you want to continue passing over the MPLS whilst migrating other traffic over to Cato. And again, of course, we're not using the public internet for the entire journey, so it can be latency sensitive real-time traffic that you pass over Cato if you want to free up some of the bandwidth on the MPLS. So that's one of the options, the MPLS augmentation approach. Now, the other option is that in time, and this is probably where most of our customers will move to, because we have the backbone and we are able to genuinely be an MPLS replacement and give you the benefit of increasing the bandwidth you have available to yourselves compared to the MPLS for the same type of cost, then of course it makes a lot of sense to look at maybe completely replacing the MPLS circuit and using Cato. So that tends to be that second step and often the end goal for our customers. Now, a point here, just to make sure it's very clear, this connection from your site, either over IPsec or from our socket to the nearest POP, is running over the last mile internet. We have ways of mitigating and reducing the perceived risk of doing that. We'll talk about that in a moment, but internet circuits are required at each of the locations in order to extend those locations securely into the Cato cloud. Now, from the cloud data center perspective, naturally, this is a big part of a lot of organizations' infrastructure, and a lot more of the organizations are migrating across to cloud data centers. We also have an approach of connecting those locations into Cato, and in fact, we've got two approaches. One can be to use the native VPN gateway that is present within Azure, within AWS, and we can simply create an IPsec tunnel, in fact, two for resilience, to that location, and then it simply appears as yet another Cato connected site to which we can allow traffic to access from any of your other locations, and make it very easy and manageable, and essentially abstract the fact it's a cloud data center and just look at it from the perspective of, hey, it's another connected location that hosts resources that you need to access. Now, the other approach is we've got a vSocket, a virtual socket that can reside in these locations. And to be honest, it really is down to the particular customer scenario as to which is the best one. We can go into more depth in that at a later stage if it becomes relevant. Then the final piece on the right there, you can see is the Cato Client, which is our means of being able to connect the mobile users, those who are outside the Cato connected offices, allow them to also take advantage of all of the Cato offerings. So for iOS, for Android, for Mac OS, Windows, Linux even, we have a Cato Client that you can install, which will act very much like the socket device, but as a client, and identify which is the nearest Cato point of presence depending on where you currently are in the world. So it will connect securely over whatever internet circuit you're giving it, whether it's 4G, whether it is Wi-Fi or whatever. It will find the nearest POP and it will securely create a tunnel from the Cato client, from your device, into the Cato POP, And at that point, you get all of the same benefits as being in the office. So the great thing about the whole cloud native approach that we have is that every one of those 43 points of presence has full awareness of all of your policies, all of your configuration that you may have as a customer. So if you go for traveling over to Singapore, even if you have no office there, when you connect with your Cato client to the Singapore POP, you get all of those same benefits available to you via that Singapore POP. And what's particularly nice is that it's really giving you the benefit of having what is like MPLS in the pocket, because you're jumping onto the Cato backbone locally to wherever you are, and then you can leverage that Cato backbone to get to your destination. So you're getting that same kind of MPLS benefit even when you're a mobile user that's traveling. Now, a little bit about the backbone itself. I mentioned how we're using tier 1 carriers. So for each of the POPs where we have been strategically placing them to meet key business requirements, wherever possible, where there's a tier 1 carrier, we'll use multiple tier 1 carriers peering into our POP in order to give us resilience and also access to SLA-backed connectivity. Now, what this means is that we're able to far more effectively control the path traffic will take when it's passing across our backbone. Plus, it means we're very often not even having to go through more than one ISP exchange point. So packet loss, latency, jitter are all dramatically reduced compared to the public internet. And it also means that we're able to apply optimizations that I'll touch upon in a further slide. Okay, so the backbone is really key to our offering. The other point is every single one of our POPs is fully configured and fully serviced with the security inspection capabilities as well as the networking capabilities. So they all have that same ability to provide the service to you, even if you jump from one POP to another due to maybe a maintenance period or whatever. Now, another piece which we'll often get as a question from organizations wanting to move or considering to move away from MPLS is we're at the moment with an MPLS provider, with a telco, we may have some challenges with it, but at least we've got one place to go if there's any issue. And if you go to an SD-WAN solution, the perceived risk is that, well, we know you've got to go for ISP links, and then you have the SD-WAN provider. How do we know where there are problems, and how can we manage that last mile without having to deal with lots of different entities? So we've introduced down the bottom, you can see here, a service which is called ILMM, Intelligent Last Mile Management, which essentially allows us to take that pain away from organizations. So when you have multiple different ISPs providing your last mile connectivity across your potentially multiple offices, globally even, what we want to be able to do is say, let us monitor those links, give us the authority to raise tickets on your behalf, and then what we'll do is, using this service, we will continually monitor and profile what is the normal connectivity health, and if we see any issues or deviations from that profile, then we'll proactively go to the ISP, raise the support ticket, take it all the way through to resolution on your behalf, and keep you up to date. So we're taking away that pain of you needing to try and figure out, oh, is it Cato, is it the ISP that maybe we need to talk to? We'll deal with that on your behalf. So this next slide is going a little bit deeper into the technical side of things. So in this example, we've got a branch office, we've got an HQ. We're looking to connect the two of those together, and you've got maybe an existing MPLS circuit. So we can see here that what we do is we position our Cato socket at the perimeter, and in this case, we can see it's being followed. Our best practice is being followed to have two ISP links connected into the Cato socket, ideally diverse connections, and maybe for a period of time we've also got the MPLS circuit in place as well. So using those two ISP links, we extend the traffic and create a tunnel into the nearest Cato POP, and we do the same for the other end, and obviously between the POPs we've got the Cato backbone. Now what we do is leverage those ISP links in an active fashion. We want to allow you to make best use of both. So we can do that from a load balancing perspective to share traffic across the two ISP links. It also allows us to be able to apply some pretty cool features such as packet loss mitigation we'll talk about in a moment. But in terms of the multiple transports, we're not only able to use the ISP links, but as I was mentioning before, if you're looking at maintaining the MPLS for a period of time, we can also decide intelligently which traffic we're going to pass over the MPLS circuit, and you have complete control of this yourself as well, and which traffic passes over Cato. So for a period of time before the contracts expire for the MPLS, you could start to offload the congestion from the MPLS circuit and use Cato. This also gives you the opportunity to build that confidence that we do what we say we do, and it is a genuine MPLS replacement option. Now, with those Cato sockets, we're also able to apply at that point for the end-to-end connectivity quality of service, so that we can best make use of the bandwidth that's available. So if you're getting to a point where there's any type of congestion with the bandwidth available, we can apply prioritization to ensure that you're going to have your more critical applications prioritized over the less critical. And there are quite a few options there which will allow us to, or allow you, because you can configure this as well, to decide how you're going to carve up that bandwidth and how the prioritizations are going to work. We're also able to identify identity. So we can hook into Active Directory, and we're able to retrieve real-time information about the users and the user groups. So in particular, having user group information means that when we identify a user has logged in and we identify traffic relating to that user, we can have policies both on the security side, the QoS side, the link selection side, based not only on user, but also whether they're part of a certain group. And beyond that, we can obviously also decide upon link selection and QoS and all of the rest of it based on application that needs to pass, destination, source, essentially a whole host of match criteria that we can use to be able to make smart link selection choices and QoS choices and packet loss mitigation choices for the traffic that you need to pass. So talking about the packet loss mitigation, what we've added to the capability within Cato is to say, for particular traffic that you deemed to be very sensitive, very important, that there is not going to be any lost packets, what we can do is we can leverage the two ISP links that you may have connected into the Cato socket. And what we'll say is that when you're having, let's say, a voice call or voice and video call, we'll send the traffic over the preferred circuit, but also over the second circuit as well. So we're sending a duplicate packet, and they both arrive at the POP. Now, the POP is going to figure out if there's any packet loss on the preferred circuit, and if so, it will retrieve those lost packets from the secondary circuit, recombine those at the POP, and then essentially pass the flow on with zero packet loss. Okay, so it can handle those situations where you're having temporary periods of high packet loss, or even if you experience ongoing packet loss issues, this is a great capability to be able to overcome that. Now, the middle mile is, we touched on this earlier, and one of the capabilities is obviously that, we have this backbone, which is SLA bound, and it gives us a very nice, clean, optimized pipe through which we can pass traffic. But on the basis that it is predictable, we can also provide additional optimizations you would not have available to you if you are using the public internet. So one key example are the congestion algorithms for TCP, which would, over the internet, really shrink down TCP window sizes so that the bandwidth that's available to you at each end of the circuit is not really the bandwidth you get for the entire path. You tend to get a very small percentage in order to get the reliability you need, but unfortunately that is reducing the bandwidth that's available to you. So what we can do is we can open that window size right up again without risking any lost packets, because we have the backbone, and then you're able to leverage a far greater percentage, like looking at 85, 90% of the available bandwidth you have at each end, but instead for the global connectivity. So you tend to find there is very often orders of magnitude increases in the available bandwidth for the WAN connectivity, more prevalent the greater the distances. Now, just finishing off this slide, the site-to-site and site-to-cloud data center connectivity is not the only piece the backbone can be used for, but also if we're looking at things like Office 365, a SaaS application, which may be hosted in, let's say, Amsterdam, we can also optimize access to those kinds of resources, which is particularly useful when you have a global footprint. So if you're looking at having locations in Hong Kong or China or Singapore, for example, and they need to access Office 365 and it might be hosted in Amsterdam, what we're able to do is say that we can recognize that type of traffic and we can say, right, if it's Office 365 traffic entering into the Cato Cloud from anywhere in your global footprint that you may have, we will ensure that the traffic passes over our backbone and always exits out of a predefined POP, in this case, the Amsterdam POP. So we're literally depositing traffic right on the doorstep of those SaaS services rather than relying on the public internet to get there. You're able to use the Cato Cloud. And on this point, we're actually increasing the amount of points of presence at a rate of about 2 to 3 POPs every quarter. So it's an ever increasing footprint that we have. Okay, so in terms of the security piece, this is, as you would expect, enterprise grade. We've got Shlomo, who would never put his name to a security solution unless it really was at the level that would be expected by organizations. And what we've built into the Cato Cloud is the ability to have WAN firewalling to control traffic that passes over the WAN, over the Cato Cloud from site to site. So rather than MPLS, where it's literally an open pipe which needs security overlaid on top of it, we're building WAN firewalling directly into the Cato Cloud, so you can be absolutely in control of where that traffic is able to pass. We've also built in IPS, intrusion prevention services, anti-malware services for traffic passing across your WAN, as well as any internet-bound traffic. And to supplement that further, for internet-bound traffic, we've got a enterprise-grade URL filtering service, application awareness firewalling, essentially all of these capabilities that you would expect. Now, beyond that, we've also taken advantage of the fact that we see a huge amount of data every day, terabytes worth of data passing over our network, which gives us the ability to provide crowdsourced type of intelligence so that we can see new threats that are facing organizations, and we can apply mitigation to those threats in real time on behalf of our customers. So all of the security updates, threat intelligence feeds, we maintain all of that for our customers, and what we leave you with is the ability to configure the policies, enabling or disabling them, and rules to allow certain traffic to flow. We leave that to our customers to be able to maintain themselves. So we take away the headache piece and keep everything up to date, give you new features every 2 weeks without you having to perform any upgrades, and leave you to be able to maintain your policies to meet your business objectives. And then finally, just to finish this this slide deck piece off, this slide kind of shows what we're looking to do in terms of the service we're bringing to the table. We recognize that this WAN transformation that a lot of organizations are going through is including multiple different point products to get to the end goal. And what we want to do is where we can deliver those individual point products as key capabilities, key features at the grade that you need them to, it makes sense that we do so. And because we have the cloud infrastructure, it means we can do this in a very agile and very quick manner. So what we've done is we've taken point solutions such as having global policy management, being able to have mobility support, cloud infrastructure and SaaS application service support, security, SD-WAN, etc., etc. We've consolidated that and converged that into a single stack, which is the Cato Cloud. Okay, now it doesn't mean you have to use every one of those. A lot of our customers will do, but if it's part of a roadmap and journey that you need to take, you just focus on the key use cases initially, of course, that's absolutely fine. We're not saying you have to replace everything in order to use Cato, not at all. We've got a very well-versed approach of being able to have a gradual migration as needed, but the point is, we have got these capabilities all built in and available for our customers. All right, now we have about 20 minutes or so remaining. So if you give me just 1 second, I'm going to give you a 5-10 minute run through of what the UI looks like. And then what we'll do is open this up to any questions that you might have. So if you can just give me 1 moment and I will figure out sharing a different screen. Okay, 1 second. Okay, and Michael, maybe you can just jump on for a second and let me know whether that browser window is now visible.
I can see that nice and clearly.
Superb, superb, superb. Good. Okay, so what we're looking at here is the what we call CC2, Cato Console 2. It's the global management interface that we have. Obviously, you can see it's browser based. This is really your one-stop shop for all of your setup, your configuration, your monitoring, and your management of the Cato solution. And what we've got here, first of all, is a landing page which is giving us a quick visibility of the current status of the sites connected into Cato. So in the middle with the green ring there, that is of course representing Cato Cloud. And we've got a number of locations here. Some are cloud infrastructure, some are physical locations. And we can see here that other than that Tel Aviv office we have there, all of them are currently connected. And we can see that they're connected here, this one, to the Ashburn POP and so forth. So this is a very quick view of the currently connected sites. Now, also, if you have users connecting in, you'll get to see them here. We can see Sean is connected in using his, looks like a MacBook, but he's connected in using the Cato Client. Now, from here, what we're able to also do is if I was to maybe click on any one of these sites, we can get a very quick view of the current status of that site. This is really a demo environment, so there's not a huge amount of traffic passing through this one. So I will be jumping onto another account in a minute to show you something more interesting. But this gives you an idea of how it looks when you're connecting sites in. Now, in terms of how easy it is to Cato connect a location, really there are two aspects to it. One is from within here, we create this definition of a site. That's a very simple process of going through this site wizard where we put in some basic information, which will simply create a visual representation of the site that you want to connect within this view here. It's then ready and waiting for the next step, which is to have, and let's just take the example of a Cato socket, waiting for the socket to be available. Now, these socket devices, as you saw, they're defined as zero touch or as close to as possible. The reality is they need to be able to reach the internet. So if that can be done using DHCP on the WAN side, great, then it's zero touch. Otherwise, you might have to put a static IP on there. And once you've done this and the socket is in place, factory defaulted, so no other configuration, it will attempt to reach out to the internet, identify where it is, find the nearest POP, and then it would announce itself within this console that we're in at the moment. So in this little bell icon, it'll announce that it's been detected, and you simply then map it to the site you've created, and then that site is connected. It's as simple as that. Now, if you have multiple internet circuits coming in, obviously we just connect all of those circuits into the Cato socket, and those will also be leveraged. But on the basic level, that is as complex as it is to get a site connected. Okay, so very simple approach. Now let's just jump ahead and let's have a look at one of our other accounts. So this one here is essentially our Cato Alpha account. This is being used by members of our company. So there's a lot more traffic going through here. And if I jump across to analytics, I want to give you a bit of a run through of how it looks once traffic is passing from a location into the Cato Cloud. And what we can see here is the Israel office, and at a very high level at the moment in terms of the last day and the traffic volume we're seeing coming in from that location. Now, this actually has 3 internet circuits connected in, okay? And we can see each of the 3 here, and it's represented on the graph. Now, if I drill into that Israel office, the first page I get to when I'm looking at the analytics is the connectivity page, which will give us visibility of the health of the last mile circuits that are connecting that location into the nearest Cato POP. Here are the 3 circuits, BizNet, Bezek, BizNet here as well, and then the consolidated bandwidth coming in from those 3 circuits into the Cato POP. Now, what I can do is, having looked at here the last day, but I can change that should I want to, I can hover over these graphs beneath, and I can see then metrics for any time that I'm hovering over during that day. And I'm getting to see information about what is the upstream throughput, the downstream for each of the circuits that are being used. I can see packet loss. I can see packets that are being dropped as part of the QoS policies. I can see jitter, and I can also see what is the round trip time for that location to get to the nearest Cato POP over each of those 3 circuits. So that's great from a health perspective, and it may be that I decide I'm interested in a certain period of time, and I can drag over it, and it will zoom in, and it will give me information then about that particular time, and I can see peaks and troughs of the traffic flow. But it doesn't give me any details here about what kind of traffic it is. So what I can also do is I can drill in here, have a look at usage, and it will show me that zoomed in period that I just selected, and it will show me what are the contributing applications, domains, even hosts to that traffic that I'm looking at the moment. So for example here, this is all of the traffic that is currently passing through from the Israeli office during that time period. But what if I wanted to say, okay, how much is that annoying Apple software update from iPhones and everything else contributing to the overall traffic flow from that office? And you can see here, it'll highlight when there were the periods of time from Apple software updates. And I can do the same for domains. I can do the same for particular users, see who are the, wow, okay, so here, this guy, he's leveraging a lot of the data, a lot of the bandwidth during certain periods. And it allows me to identify certain trouble spots, things which maybe I need to rectify using QoS or restrictive policies and so forth. So it gives me a good amount of detail. Now, if I wanted to see this more from the perspective of how is the traffic during that period fitting into the various different QoS policies that we have defined, I also have visibility of exactly that to say, are my QoS policies working right? Have I got a good even distribution across those QoS policies? Was there any packet loss, et cetera, et cetera? It gives me visibility to be able to see exactly what is going on and therefore control what is going on should we find that we're having overly congested traffic. Now, there's a lot I can show you, but one other thing that I really do want to show you is this real-time capability as well, where we're able to take that, that same kind of view, but from a real-time perspective, not just historic. So I can look in real time from that office over each of the circuits. What is the current traffic flow? What is the bandwidth being used, the latency, the jitter, the packet loss? And I can drill in and look at who are the highest contributing users right now to the traffic coming out of that office, and what are the applications being used. Okay, so this is really useful for us. Again, if there's a real-time issue, you get this visibility in real time to be able to make decisions. And what I really like is the fact that we're not just looking at it from a transport perspective, but if I go over to QoS, I can see in real time, how are my QoS policies working? Have we got a good distribution of traffic for those, or have I got it a bit wrong? Is the traffic I expect to match into P3 actually the traffic that is going through it at the moment? Gives you that kind of visibility. Okay, now there's a lot more I can go through. I'd love to show you policies and the security and so forth, but this is really just to give you a flavor of what we do. So what I would say is that in the interest of time, to give a little bit of time for questions, I would say that if anybody did want to go deeper and talk more about their particular environment and potentially projects and wanted to have a bit more of a deep dive, then we should maybe do that as a separate session. So what I'll do now, Michael, if I kind of hand over to you for a second, and maybe you can let us know if there have been any questions raised throughout the session.
Yep. So so far we haven't got any. If there are any questions, please feel free to post them. If you do want to go through through a more in-depth demo, then we can
okay.
organize that.
Yeah, why not? Why not?
Well, I was going to say we can organize that through the Bytes account manager, maybe at a later stage.
Yeah, that makes sense. That makes sense. So I mean, naturally absolutely. So naturally, we're more than happy to kind of talk through the solution further. I guess the closing points that I would like to make is that if you're an organization that has WAN connectivity requirements and you're currently using IPsec or MPLS, or if you have cloud adoption projects, then these are the types of scenarios where we tend to find there are challenges organizations have that we are very well positioned to be able to meet and to be able to overcome. So please feel free to reach out. Thank you very much, everybody, for your time.
We have received some questions. Just
great. Okay.
No, sorry about that. So we've got one. Can we see some security features?
Yeah, well, since we've got a bit of time, let me just go across and talk through some of those. And if you just let me know if any other questions come up as we're going along, so that I give a bit of time for those as well.
So we've got another one. What is the encryption method between Cato Socket and the nearest POP? Maybe you can answer that while you're getting onto this.
Yeah, absolutely. Absolutely. So, so yes, it's a quick one to answer. So the encryption methods that we use for sites going to the POPs and even between the POPs is DTLS, datagram-based TLS. So it's essentially TLS, but using UDP. It allows us to minimize the overhead and optimize the throughput whilst maintaining the level of security that's needed. Now, naturally, every single site that's connected in and customer coming in has a unique key so that we're keeping traffic segregated and segmented between the customers and between the sites. But yeah, that's what we use. Okay,
great.
Good. So just looking at the security services, so you can see here on the left that we've got WAN firewall, internet firewall, URL filtering, and threat protection. The WAN firewall, as I touched on earlier in the presentation, is there to allow us control between sites, between corporate elements. And the way that it works is that per rule, you're able to specify what is the source, what is the destination, do we want it to be bidirectional or unidirectionally initiated traffic, and we're able to define the source and destination by either logical groupings, by entire sites that are connected in, hosts, VPN users. If we hook into Active Directory, we can also do it based on AD user and user group, subnets, floating ranges, etc., etc. So the granularity there for us to be able to control what is able to pass over the WAN is very powerful. Plus, if you want to add some additional constraints, we can then also add the specific services, time, and so forth as additional constraints for the traffic that's allowed to pass. So that's on the WAN side, the WAN firewall. For the internet firewall, if we go across here, you can see that we've got the option at the application awareness level to be able to block and also create exceptions for certain applications. So you'll see that we've got similar type of convention for creating the policies here, where we have a source and a destination, with the destination being able to be either categories of applications based on our application awareness, so things like Office 365 and so forth. We maintain knowledge of what that means, IP addresses and URLs, specific TCP and UDP services, and then also a number of other criteria in order to be able to match the traffic and decide what is allowed or not allowed. Now, we also overlay that with URL filtering. So we maintain this, this feed in real time. You don't have to worry about it yourself in terms of keeping the categories and the URLs that match those categories up to date. So here you can see we've got a number of categories and quite a few more pages worth, and the default action that we would typically recommend, whether it's allow, block, monitor, or prompt, but you have total control of being able to change that, plus add your own custom policies based on, you know, users or groups that may need slightly different access to the defaults. The final bit and the back end of this is maintained by our SOC team to make sure that we're keeping false positives to an absolute minimum, is to be able to enable anti-malware, next-gen anti-malware, IPS in the different flows and directions of traffic through the Cato cloud, plus additionally the ability to apply geo-restriction for countries which you believe may not be needing to do any business with you. So you can control that in either direction, but you're able to restrict access for certain countries. Any other questions coming through, Michael?
Yes, we have one more. It is, would it be possible to use two-factor authentication for the remote clients?
Yes, that's supported. So you can leverage either SMS or you can use Google Authenticator. And then I guess the next question which we'll often get is about what about single sign-on? So we support Okta and we support Azure single sign-on at the moment. And our plan is to continue adding further providers since we've got the framework there, which allows easy plugins.
Okay, that seems like everything, and right on time as well. So thank you everybody for joining and taking the time out your afternoon to be here, and thank you to Mark for presenting. That's been we've got one more. Quick one.
Sure.
Do you do WAN acceleration?
Absolutely. Yeah. So the WAN acceleration that we touched on earlier. Well, it depends on what people refer to as WAN optimization, WAN acceleration. Certainly, what we'll do is in the backbone, we're going to be accelerating traffic by applying smarter TCP congestion algorithms, which will the number one method to really increase available bandwidth to the customers compared to MPLS or the public internet is by opening up the TCP window. So what we're not doing is caching. We're not applying any dedupe. We're not doing anything that would require you to go into each application and configure that separately in order to make sure that you optimize it and don't break it. But instead, we want to keep things simple, leverage the fact we've got a backbone, which we can optimize traffic there and do it as a blanket optimization rather than one that requires you to have ongoing administration to make sure your applications don't break.
Okay, great. So I think that's it then. So again, thank you everybody for your time, and I will be sending the recording out to everybody as well. Thank you for joining.
Yeah, thanks everybody.